In homework 5.5, we are completing the square and simplifying radicals. On the front, I'll just do 1. These are all kind of difficult completing the square ones. I'll do number 4. On number 4, we need to complete the square, and the thing that makes this a little bit tricky is this 1/3. The first thing we do when we're completing the square is we're going to rewrite it with the -1 kind of separated off. We're not even going to use that -1. We're just going to kind of put it over here. This is the part that's eventually going to become a square binomial. We really want this x squared to be by itself, and so what we're going to do is factor out this 1/3. 1/3 times x squared plus 1/3 times what gives you 6? Or gives you 2. 1/3 times 6 gives you 2. 1/3 of 6 is 2x. Notice that you can often think of factoring out as dividing by whatever it is. When you divide by 1/3, you're really multiplying by the reciprocal, which is multiplying by 3. So here we have the same thing rewritten. And now we need to complete the square. Let's go forward one more step. Eventually, this is going to become a squared binomial. And to make it a squared binomial, we know we have to square the first one. That has to become x squared, so it's going to be x. X squared becomes x squared. We multiply these two together and double it, and that's going to end up becoming 6x. So our scoring binomial shortcut says we multiply these two together and double it. So this number must be 3. 3 times x is 3x, doubled would be 6x. Now, there's another part when you square the binomial. You square it, multiply it together and double it, and also square the last one. And that's what the completing the square is. To make it be the squared binomial, we really need a +9 here. But this +9 isn't really a +9. It's getting multiplied by 1/3. That +9 is really only a +3. So look what we did. In this red here, we added out of nowhere a +3. It's no longer equal to our original equation. So to make it equal to our original, we cancel out adding 3 by subtracting 3. So here was our original. We added 3 and subtracted 3. It's still the same thing. Notice, even though this says +9, we're not subtracting 9 because it's really only adding 3. So we subtract 3 here. We can combine these like terms and get that f of x equals 1/3 x plus 3 squared minus 4. Now we need to graph it. We have a horizontal shift left by 3 and a horizontal translation down by 4. So our vertex, instead of being at 0, 0 like it is on the parent function, y equals x squared, will be 3 to the left and 4 down. We also have a vertical compression by 1/3. X squared, 1 squared is 1, but 1/3 of that will be right here. 2 squared is 4. 1/3 of 4 is 4/3, which is 1 and 3/3, 1 and 1/3, sorry. When you do 1, 2, 3, 3 squared, when x is 3, 3 squared is 9, 1/3 of 9 is 3. 1, 2, 3. Here's our parabola. It'll be the same thing on the other side. Looks like this. So that's what our parabola looks like. You can tell you did it correctly if it fits on the graph. If it doesn't fit on the graph on these other 3, you probably made a mistake somewhere. All right, let's look on the back. We're supposed to be simplifying radicals. So I'll do a couple. To simplify a radical, we're making use of the fact that if you have the radical of a times b, that's equal to radical a times radical b. And we're going to use that to simplify it. Now this only helps us simplify if one of these you can do the square root of. So what we do is we look for square numbers that can go into this. So I notice this is even, which makes me think 4 has a good chance of going into it. So I'm going to do 288 divided by 4. 4 goes into 28 7 times exactly. There's no remainder. And then we can bring down the 8. 4 goes into 8 2 times. So I can rewrite this as the square root of, instead of 288, square root of 4 times square root of 72. And this is helpful because we can rewrite this as square root of 4 times square root of 72, and we can do the square root of 4. The square root of 4 is 2. It's not a square root anymore, so it's a little bit more simplified. Now, we can also do something with the square root of 72 because there's a square number that goes into this as well. You know, I could keep dividing by 4, but I notice that 72 is 36 times 2, and 36 is a square number. So this is square root of 36 times square root of 2. We can do the square root of 36. The square root of 36 is 6. So instead of 2 times the square root of 36 times the square root of 2, this is 2 times 6 times the square root of 2. And we can simplify right here and say that 2 times 6 is 12. So we get the square root of 288 is equal to 12 times the square root of 2. This is the simplified form. You can't do anything with the square root of 2 because you can't evaluate it, and there's certainly no square numbers that go into it. Alright, I'll do one more easy one, and then we'll do the algebraic ones. So here, there's already a number outside of the square root. So what? That doesn't matter. We can simplify the square root by looking for a square number that goes into it. And I see that 9, which is a square number, goes into 54. 9 times 6 is 54. So this is 8 times the square root of 9 times the square root of 6. Again, it only helps if you split up 54 into a number that you can do the square root of. 9 we can do the square root of. The square root of 9 is 3. The square root of 6 can't be simplified, and we can simplify 8 times 3, which is 24. 24 times the square root of 6. That is what 8 square root of 54 equals. Okay. One more. Let's do down at the bottom. I'll do number 18. Here we've got numbers and variables. Well, we're going to use our principle of square roots that we can just split this apart. Square root of 16 times square root of u cubed times square root of v squared. Square root of 16, that's a perfect square. The square root of 16 is just 4. The square root of u cubed cannot be done, and I'm gonna leave that for just a second. Let's do the square root of v squared. Square root of v squared says what times what gives you v squared, and that's just v. But let's do this square root of u cubed. This is a little bit trickier because there isn't an exact power of u that multiplies times itself to get u cubed, but what we can do is we can rewrite it. You can do the square root of any even power, and so we're going to rewrite this as u squared times u. U squared times u would be u cubed, and we can do the square root of u squared, so we're going to rewrite this as 4v times the square root of u squared times the square root of u. The square root of u squared is just u, so we get 4 times v times u. This cannot be simplified, so it's still the square root of u. So 4vu times the square root of u is our final answer. Hopefully that helps. Good luck on the rest of your homework.